Hey students, this is Warren again. Hope you guys are doing fine. I promise you the first video coming up soon that we're making it right now. Okay, so concrete is the topic. Concrete is the topic. What is this stuff? Um, well, it's a mixture of some rocks and some sand and Portland cement. And Portland cement is made from limestone. We have an abundance of limestone in central Texas. And so concrete is not hard to get. It's easy to get. It's cheap um, and provides a lot of natural uh, conditions that we have to be able to know about. Like the term hydration is a chemical term. It's a chemical process. When we take concrete, the finished product, how did it get from liquidy mix with some Portland cement in it and some sand and gravel in it, and we mix it up, and why does it dry hard? How does that work? Well, we have a process called hydration. Follow along, follow along with me, folks. Hydration is a chemical process. A chemical process that takes a liquid substance and creates the molecules, changes the molecules to create a hard surface, a hard product, very hard. So hydration is 4 stages. It's 1, 2, 3, and 4. So we'll go over these in a few minutes. Now, when concrete is liquidy, it's called plastic. It's a semi-liquid. It's in a plastic state. Now, let's talk about this first stage of hydration. When Portland cement and cement, Portland cement and water touch, we have what we call a rapid heat gain. The chemistry is really working hard. Number 2 is a slight cool off, a slight cooling thing, and this is where it starts, and the concrete really is being put into the forms at this time. Number 3, there's a slight heat gain. This is when the concrete starts to change molecularly. You can see it if you get what's called a hot load. If the concrete's been in the ready mix truck too long, you see steam coming out of it. It's really, really, really hot. And so this is where you've got to be finished. This is where you finish. Over here is curing, and curing is a process that you do. You have to do this. It's not going to happen by itself. You have shade, you have rain, you have water, you have all kinds of ways to keep 10% of the water that was in that mix in that concrete for at least 3 days. It's really difficult to keep 90% of the water in because you don't want that in. You want it to dissipate. That is for mixing purposes only, for workability purposes only. But 10% has to stay in. You keep it covered, and at the end of 3 days, you've got a really nice piece of concrete. So when we talk about favorable temperatures and favorable moisture, we're talking about the curing process, the last stage of hydration. So we want that to last as long as we can. So this is Professor Warren Heatwall checking out for a few minutes. Thank you.